Hi everyone, this is a short tutorial to help you calculate the equilibrium constant for a reaction where your product is colored and therefore its concentration can be determined spectrophotometrically, that is by measuring the absorbance of the solutions. Now for the reaction between iron 3 plus ferric ion and thiocyanate, we get a colored complex iron thiocyanate, and we can know the amount of product formed by measuring the absorbance of the reaction solution. Now, how do we get this concentration of iron thiocyanate from absorbance measurements? This is the question that we address in part 1 by making a calibration curve to get an equation that will give us the relation between the absorbance of the solution and concentration of iron thiocyanate. And this relationship, this equation, is what we will use in part 2 to get the iron thiocyanate concentration there, and subsequently we will use it to calculate the equilibrium constant K. So we start with these two solutions. One is your iron solution, which has zero point 0.2 molar, and the second one is sodium thiocyanate, which is way more dilute, 0.0004 molar. And we do this because we want to make thiocyanate as the limiting reagent so that whatever amount of thiocyanate is present, it's all converted into your iron thiocyanate complex. It's like you have 200 bread slices and 10 slices of cheese, and you want to put together one cheese between two bread slices. So if you have 10 cheese slices, you will get 10 sandwiches. So with that correlation between the concentration of thiocyanate and iron thiocyanate, we make 6 solutions. And then what we are doing is we are keeping the amount of iron constant. And since you will use burette for measuring volume, we will write two significant figures after decimal. So these are the values that you would be writing from the burette, and I will type something randomly here. So let's say around 1.98, 2.01, 1.98, 2.05, 1.99, 1.98. All right. Now, similarly, we will use sodium thiocyanate, and here we will use increments of around 1 ml. So the first solution without any addition, and this is your blank solution. This is the solution that we will keep in the reference cell compartment of the calorimeter uh, in part 1. So let's say your first solution is 0.98, 1.95, 3.15, 3.96, and let's say 4.96. All right. So this is how you have made 6 solutions, and now you want to know the concentration of thiocyanate, which is different from the initial concentration because you are putting together those two solutions and bringing up the total volume to 10 ml. So for getting this concentration, we will use M1V1 is equal to M2V2, where M1 V1 M1 is your concentration, initial concentration, V1 is your initial volume, and M2 is what you want to figure out, the final concentration, and your final volume is 10 ml. So let's use Excel function equal your volume times concentration, and concentration is here. Now this is important. We want to populate all these cells and without changing that number. To keep that constant, what you do is you need to put $sign in front of it. Either you can type $sign or you can simply press F4, that brings dollar, and divide it by the total volume, which is this cell, and again you want to put $sign in front of that. Now what this $sign does, it allows you to fix either the row or column or both in any cell reference, and then you hit enter. That calculates the concentration, and you want it for all of them. Go to the corner and double click, and that will give you the concentration in all these concentration of thiocyanate in all these solutions. Now, as we said, this is your limiting reagent, so whatever concentration you have here, the same will be the concentration of iron thiocyanate. So what we do in this cell is simply equal to whatever we have here, and just hit enter, go to the corner, double click, and that is the concentration. So that's your concentration of iron thiocyanate in each one of these. All right, now absorbance measurements is what you will be getting from the instrument. And let's type some random number here too. So you will not have, you have zero absorbance for the blank, and for others 0.098, 0.181, 0.294, 0.410, and let's say 0.478. All right. So you have the concentration, you have the absorbance, and next what we will do is we will plot them. So insert and then a scatter plot. And once you have the scatter plot, you right click and add a trend line. And once you have this trend line options, you display equation on the chart and display R square. All right. So what this R square does, it's a statistical measure which tells you your goodness of fit, or how close the data is to the fitted regression line. Okay. So, all right. So this is the equation that we will be using. And this is the equation that gives you the relationship between absorbance and concentration of iron thiocyanate. So let's paste it somewhere here. All right, so what this does, or let's put it in terms of absorbance. So Y is all your absorbance values, and what you can do here is you can put the excess titles from here. Just say excess titles, and that allows you to type your absorbance here and iron thiocyanate concentration here. All right, going back. So Y is your absorbance. We can say A is equal to, then your slope is 2457.4 times iron thiocyanate concentration. So type it here, 2 plus 0.0022. All right. And let's put that as a superscript. All right. So this is the relationship between your absorbance and iron thiocyanate concentration. Right. This slope and intercept is something that you can get from using slope function too. So if you type equals slope, double click this, and then you go to this insert function that asks you known y's, which is your absorbance, and x values, which is the concentration, iron thiocyanate concentration, and you hit OK. And that gives you the same slope that you have calculated here. Similarly, you can use the intercept function, equal intercept, double click, known y's and known x values. All right, so that gives you your intercept. Now, these are the numbers that we will be using in part 2, or typically this equation, because if we are getting absorbance, you will have, you can get the iron thiocyanate concentration from absorbance using this relationship. So let's transfer this slope and intercept, Control C, to part 2. And what we do here is paste it as a link. What this allows us is if you change anything in part 1, those changes will automatically be taken care in here. You do not have to manually change anything. So this part involves the concentration of all 3 species, your iron thiocyanate and these two, because you have to plug all these to get the equilibrium constant. And in this case, we do not have any limiting reagent, and we start with same concentration, so 0.002 molar iron and 0.002 molar um, sodium thiocyanate. And again, our total volume will be 10 ml. So let's put the volume of iron nitrate solution that you will be using, which is around 5 ml each time. 4.96, let's say 4.97, 5, 4.98, 5.02, and 4.96. All right. And like last time, we will use the increments of 1, and the first is a blank solution, so we are not adding any sodium thiocyanate. Remember, we are using two different blanks. In part 2, this is your blank. In part 1, the blank was contained 2 ml of iron solution. All right, so around 1 ml, so 1.02, 0.96, 3 ml, 3.98, and 5.05. All right. So you have both the volumes, and now you can calculate the concentration using the same formula. M1V1 is equal to M2V2 like part 1. So for iron, this is equal to your volume times concentration. And again, you want to put $sign in front of that, divided by the total volume. And you want to lock it so that the number doesn't change when you change the cells. All right, hit enter. That gives you the concentration, and you go to the corner, double click. This is the concentration for all the solutions. Same thing for sodium thiocyanate, equal. So volume is this one times concentration is that one, and again you want to put $sign F4 divided by volume, and again F4, or you can type $sign, whatever you find easy, enter, and then double click. All right, so now we know the initial concentrations of iron and thiocyanate. Now, absorbance is what you will be getting from your instrument. So first one will be 0 because it's your blank solution. And then let me put some numbers here, which you will be getting from the instrument. 0.163, 0.302, 0.439, 0.593, and 0.692. Okay, let's put it like that. All right, now from this absorbance, we are interested in getting the concentration of our iron thiocyanate. And the way we do is we will use this equation that we used from the last part. Um, the equation was in the form of y is equal to mx plus c, where m is slope and c is intercept. So you will get your concentration from absorbance minus intercept divided by slope. The first one we will not be calculating anything, that's your blank. So let's go to the second one. So equal to, and what we need is absorbance minus intercept. So absorbance minus intercept is that one, and we have to keep F4 or $sign, and actually we need to put this in parentheses too together, then divided by slope. So slope is that cell, and you want to keep it constant, so F4. All right, so you enter that one and then go to the corner, double click, and that will give you the concentration of iron thiocyanate using the absorbance. And this is what we could do because in part 1 we have the calibration curve, we know the relationship. All right, now this is the easy part. You want to know the concentration of iron, and which is simple, whatever your initial iron concentration, and the initial iron concentration minus whatever was used here, right? That's what it says. Initial iron concentration minus the iron used in making the product, which is your iron thiocyanate concentration. So this is equal, your initial concentration was this one, minus this concentration, and enter. And then you double click at the corner, and that gives you the concentration, equilibrium concentration of your iron species. Similarly, to get the equilibrium concentration of thiocyanate, we go for equal. Your initial concentration is this one minus the amount of thiocyanate formed, which is this one. Enter, and then you populate all other cells. All right, so now we have all three concentrations. We have concentration of iron thiocyanate, concentration of iron, and thiocyanate. So to get your equilibrium constant equal to iron thiocyanate concentration is that one divided by this times this. So this, and actually we have to put that in parentheses, times that number, close and enter. All right, then you simply double click it, and that gives you the equilibrium constant for all of these. Now to get the average, you simply use the average function and select them all. This is your average equilibrium constant, and standard deviation is standard deviation. Select all, close parenthesis, and enter. That gives you the standard. So that gives you the error analysis as well as K average. Now, if you want to put all these calculations in your lab report, what you can do is simply go to this formulas, and here you click show formulas. That gives you uh, a view of all the formulas that you used. You can just squeeze them together to put them all in one screen. All right, so I hope this helps.